Hey guys, this lesson is how to simplify rational expressions, how to multiply and divide them as well. So we put this all in one lesson because they kind of have the same steps. You have to look for certain steps in certain order. And I'm hoping I shared with you guys a little card that tells you what steps to do for each problem for this unit. If not, someone should ask for that. But get my tablet to work here. All right, so I'm looking on the notes page, and we're going to have these two questions here, where they say simplify. So what we would have you do first is look at the question and realize, okay, which parts of this question are factorable, because that's your first step in simplifying questions. So if you have polynomials, they might be factorable, and we definitely have a couple factorable polynomials in this problem. In fact, both of them are factorable. So this whole unit, this whole week that we're learning here is going to depend on your ability to factor. Sometimes it just takes a little more perseverance on your part, right? So here we got a typical trinomial. Well, we're going to factor using the trinomial pattern. So what gives us x squared? That would be x and x. And then I need my back two numbers to multiply to negative 12, but I need the arches to add up to negative 4. So what if we used a negative 6 and a positive 2? Now, if you are considering yourself to be a weak factor or someone who makes mistakes during factoring, you need to stop and check your arches like you always do during factoring and make sure that you have the right factoring when you get to work independently. All right, we're going to do the same thing down here for x squared minus 4. That's the difference of two squares pattern. That's one of my favorite questions. So that factors into x plus 2 and x minus 2. And then our last step in simplifying would be anything that, any expression that is in both the numerator and the denominator, they cancel each other out. So this x plus 2 will cancel with this x plus 2. And that's kind of it. So you just write down what you have left. We still have an x minus 6 in the numerator. And we still have an x minus 2 in the denominator. And that is your final answer to this question. Now, I know it feels like you should do more simplifying, and if you have the urge to simplify more, what we suggest you do is put parentheses around the polynomials. Unless you see that exact polynomial, you can't cancel pieces of polynomials unless it's in factored form. So unless you see the exact factor, it's just going to stay. All right, number 2 is a little different. Simply because the numerator is what we call a monomial and there's no factoring. However, the denominator is a polynomial that we can factor. So, of course, my first step in factoring is to look for a common factor. I've got a 10x squared plus 15x. So I think our common factor in that question would be to take out the common 5x. So the numerator does not change right now. It's still a 5x squared. But our denominator, when I factor out the 5x, it becomes 5x times, 2x plus 3. So that's that undistribute or pull out the common factor kind of factoring. So here is a case where we have monomials, which can be broken up into pieces. All right, think of it this way. This is like 5 times x, and this is 5 times x. So can you see that the 5s are going to cancel? And then this is a little tricky. Because think of x squared as x times x separately. One of the x's will cancel, right? That's what's happening there. So our numerator still has an x in the numerator. And then our denominator still is the polynomial of 2x plus 3. And that is your final answer for that simplifying question. Okay, so yes, it depends on your ability to factor and then to carefully cancel terms. Now the good news in number 3 is that there's no polynomials, there's only monomials, but they're kind of all over the place. So what we're going to do in this problem is we're going to smush the numerators and denominators together. I know it's not an official math term, but that's what we're going to do. So in this numerator, if you were to multiply and combine all the terms you can, that numerator becomes a 30 because of the 5 times 6 for the coefficients, and then we've got x to the add them up, that becomes x to the 5th. And then remember there's like a 1 here, so y to the 3rd. And if I smush the denominators together, let's see, that's a 20 for a coefficient. And then we got an x, or an x to the 1st if you want to write it that way. And then y to the, add those up, we get y to the 4th. So we know from our work with exponent problems, this is not done, this is not simplified. We're going to start by simplifying our coefficients, and that could be something that you just type in your calculator, but you need to reduce 30 over 20, and that reduces to a 3 over 2. And then for the exponent rules here, or some of your visual simplifiers, that works too, you're going to subtract the exponents. You can't read that. All right, so 5 minus 1 would be x to the 4th. And then 3 minus 4 is negative 1 for the y. Now, remember your exponent rules. Some of you already did this step, but this y actually ends up going to the denominator, which means that it's now a positive 1 in the denominator. So we have 3x to the 4th up top. And then in our denominator, you've got a 2 and then a y to the 1st, or you can just say y. I don't care. So those are some simplifying questions we might see. You know, questions where you got to factor and cancel, questions where you partially factor and partially cancel, questions like this where you kind of smush the monomials together, simplify, and then start canceling things. And then we get a question like this. So now we're supposed to multiply these together. It would be my worst nightmare if you guys literally multiplied these together in the polynomial form. That would be atrocious. So think back to 4th grade. Before you multiplied fractions together, your teacher encouraged you to cross-cancel. So that's what we're going to do here. We're going to factor everything we can, see if there's any cross-cancellation. And if there's cross-cancellation, that's good news, because that means we're going to have less things to multiply together, you know, in theory. So everything I highlighted is factorable. This is one of those traditional trinomials, right? So this guy factors into, let's see, x plus 3 times x minus 2. That would multiply to negative 6. But the arches would add up to 1. Okay, this guy here, it's the kind of factoring where you take out the common term. I know that doesn't sound very exciting, but it's important here. So that common term in this problem would be a 2. Okay, and then down here, this is just a traditional trinomial. So I'm looking for numbers that multiply to 12, but the arches have to add up to 7. So we would try 4 and 3. Okay. Couldn't do anything with the monomial right now. We'll worry about that in a minute. But one thing I want you to understand, guys, is this is one big fraction now. So anything that shows up in the numerator and the denominator, any term, can cancel. The thing you got to remember about the monomial, though, is remember it's separate. It can separate a monomial. So 2x squared is really 2 times x times x. Keep that in mind. All right, this is my favorite part of the problem, crossing stuff off. So the x plus 3s are gone, and the x plus 4s are gone. And then the 2 is gone. So what do we still have? Well, you still have an x minus 2 up in the numerator, and you still have an x times x or an x squared in the denominator. And that's your answer. So our answer of x minus 2 over x squared. I know, it doesn't seem that exciting now. But trust me, that was way more fun than trying to like put the whole polynomial sets together and then try to factor. That'd be awful. So here in number 5, I need you to go back and think about what you did back in 5th grade with fractions when I asked you to divide. So we can change it to a multiplication problem as long as you remember the rule of, well, you're supposed to take the fraction that follows the division sign, and you can change this to a multiplication sign as long as you flip the second fraction. So what I'm going to do in this question is I'm going to kind of rewrite it, factor it, and flip it like all at the same time because I don't have a lot of space. So let's talk about factoring for a minute. Which are the things that factor? Well, this is going to factor, and that's going to factor. You guessed it, guys. Every single thing in this problem is going to factor. So let's keep that in mind. What I'm going to do in this problem, though, is I'm going to kind of color code where these are coming from. So I'm going to call this the green problem. And when I go to factor the green problem, it's the kind of factoring where you take out a common term. So we're going to take out a 5x from that expression. If you took out a 5x, you'd still have an x plus 2, right? That's the undistribute kind of factoring. Okay, I'm going to call this the red problem. Trinomial has to multiply, the back numbers have to multiply to negative 6. The arches have to add up to negative 1. So methinks a negative 3 and a positive 2 would do it. All right, remember, I'm changing this to a multiplication problem. So we're going to change that. And then now I have to remember that I'm flipping this fraction. So I'm going to call this next one the blue one. But he's actually going to go down here in the denominator. So that problem gets factored by taking out the common factor again. A greatest common factor here would be a 15 and an x squared. All right. Now if I took out a 15x squared, I still would have an x and then a plus 3 if I undistribute that. All right, and then our final factoring problem, my favorite one, x squared minus 9. That's the difference of two squares. That's the good twin, evil twin question. So that's an x plus 3 times an x minus 3. All right, now for my favorite part in this whole problem, remembering that this is one big numerator, you can start, one big fraction bar, you can start crossing off anything that shows up in the numerator and denominator. Let's see what we got here. I'm going to have to use a highlighter to cross them off. Okay. So the x plus 2's are gone. And then the x plus 3 is gone. Ooh, the x minus 3 is gone. And maybe you're not really sure what you have right now, guys. If you're not sure, what you could do is you could write this 5x. I'm going to write down here, actually, just as 5 times x. And then in the denominator, this 15x squared, what I'm going to write that as is a 15. Oops, I'm supposed to use blue on that one, I think. And then instead of x squared, I'm going to write it as x times x. Now, you could have gone further and broken up the 15 if you wanted to, like into 5 times 3. But either way, I'm going to need you to reduce that. Actually, let's go ahead and do that. Why not? Get crazy, Abruzzo. All right, 15 is 5 times 3, huh? Why would I want to do that? Well, I'm going to show you. A 5 would cancel, an x would cancel, and look what you still have. Now, we have, quote, nothing in the numerator, but we have to have something. So you have a 1. And then 3 times x is what you still have in the denominator. That question is so, it's like a sand trap of math. It's like all this factoring, you have to remember to flip it. The canceling got kind of weird. I really like that question as your math teacher, but I can understand as a math student where you might be a little confused. So I think the moral of today is watch your factoring, go slow on the factoring, double check your factoring, because we know if we factor things wrong, it's going to blow up the rest of the problem. Now, in theory, they could combine those two types of problems. They could give you a multiplying and a dividing question all at the same time. But the rule still states that you can change this to a multiplication question as long as you flip this. So the fraction that shows up after the division sign is the one that gets reversed. So the good news is there's not a whole bunch of factoring in this question. In fact, I think there's only one thing I can factor. I think we needed a break after that last question. All right, so x over x plus 5. Nothing I can do there. The only thing I might want to do, though, is put parentheses around the polynomial. That helps. This one already had parentheses around it. The other thing, though, I might want to add to this fraction is to make it look like a fraction. So call it 3x minus 5 over 1. And then remember, we're changing this to a multiplication sign because we're going to remember to flip this one around. So again, I'm going to put the x plus 5 in parentheses up top. And then down here, this problem, this gets factored using the difference of two squares. So that would be a 3x plus 5 and a 3x minus 5. All right, big fraction bar, guys. Giant problem. Anything numerator to denominator can cancel. So I'm seeing an x plus 5 is gone. I'm seeing a 3x minus 5 is gone. Watch out. Don't cancel the wrong thing, Abruzzo. And then what do we still have left? Well, we still have an x up in the numerator, and we still have a 3x plus 5 in the denominator. This is your final answer. The only thing you might want to consider doing, just to show that you understand that 3x plus 5 is its own term, put the 3x plus 5, leave it in parentheses. That, my friends, is your lesson on simplifying and multiplying and dividing.